Hey everybody, I'm Jose. I'm an electrical engineer that works as a quality systems manager at Intel Corporation, and I get to break stuff for a living, believe it or not. I work for a lab that actually stresses parts that are going to be sold out into the field. Manufacturing silicon is super hard. Packing millions upon millions of transistors in a tiny space like this is not an easy task, and yet we've been able to do it on a steady cadence year after year and pumping out wonderful products that are now powering the internet, and they're powering the devices that most likely you're working on or actually viewing this video on. To give you some context of what we're doing here, when you manufacture a device, you have to think of it how it's going to be utilized out in the field and how it's going to get to your hands. They'll go on a plane, they'll go on a boat, they'll go on a truck. A lot of things can happen in that process. They can break, they can fall, they can be thrown on the back of a truck. So our devices have to be able to survive that stress of just getting into your hands. And once they're in your hands, you could easily drop a device, your little brother can push it off the table or whatnot. These are the kind of scenarios that we actually plan for and we actually have to account for in the process of generating our products. When you drop a device, you're dealing with mass, you're dealing with acceleration, you're dealing with force. All of those things are calculated, and we create models that our quality and reliability engineers use to verify that effectively the devices can survive those stresses. So remember, when your teacher's talking to you about force, mass, acceleration, those things apply in the real world. They're all around you. If you're moving in a car, if you're dropping your phone once again, even if you're walking and bumping into your buddy, physics is all around you. We breathe and we live physics, believe it or not. How do we solve complex problems at Intel? We need to work as a team. You can't solve an issue in an isolated world. In reality, everybody brings their experience and their knowledge to the table, and that's exactly what we like about diversity. We use different backgrounds, different views, and different standards on how to solve an issue in order to solve very complex problems. So the methods that you're actually using right now in class is exactly what we do on a day-to-day basis. We create models, we create hypotheses, and then we test them. And inevitably we're going to fail, but we learn from those failures, and then we adapt the model that we created to the new data that we have. So in essence, we're having fun every day. We're building things. We're actually creating things that didn't exist before based on the knowledge that other people are generating. So, we're knowledge creators ourselves, and we're generating new content, and we're generating new devices. So it can be anywhere from software to mechanical devices or electronic devices. So engineering is actually pretty cool. If you think about it, we're creating stuff that didn't exist before. All those bright ideas that you have right now, using the proper methods and using structured problem solving and using diversity and thought will allow you to take those bright ideas into actual products and actual solutions that can effectively change the world. That's how things generated from a concept to a light bulb, from a grain of silicon to an actual microprocessor. And again, we haven't solved everything. There are problems yet to be solved, things that we need to be discovered. You are the next generation that's going to take these ideas and transform them into reality. So, I challenge you, go use the knowledge that you're gaining right now and go make a difference. Change the world.